Hey, hello, welcome to the show. It's me, JP. This is John Park's workshop on CircuitPython Day. So yes, we're, as Thin Man said, a day late, but hopefully not $1 short. You're in the right place. Just it's the wrong day. Usually I'm here on Thursdays, but it's CircuitPython Day, so we decided to gang up all the shows, and here I am. I hope you have been able to enjoy some of the other broadcasts. I've been enjoying watching a whole bunch of different CircuitPython based shows, podcasts, show and tells, and more all day. So you can go and catch up on that stuff if you want. If you missed it, that's okay. Go over to YouTube and you will see all of the shows from throughout the day are there. So there's plenty of CircuitPython Day content for you to go and check out if you're interested. I am gonna, first of all, let you know what we're up to today. I've got a coupon code to share with you, a CircuitPython Day coupon code, so you can save some money in the shop. I have a recap of my product pick of the week. I've got a CircuitPython Parsec. I'm also gonna do a little bit of a CircuitPython Parsec retrospective from the year to just kind of cover what I've covered. I have a, what else? I think same sort of thing with Learn Guide. I want to pick out a few Learn Guides, CircuitPython-based Learn Guides that I've done over the last year to chat about those. And then I've also got a little bit of a CircuitPython demo with the kick drum pedal, the electronic kick drum, electric kick drum pedal. Either way, there's no real drum involved, but there will be some CircuitPython and a Metro RP2350, I believe, hooked up over there. You can see Lars is there. He's the roadie for the day, so he's setting things up. Speaking of the Discord, thank you to, oh no, wait, that broke. Hold on. I'm going to go fix that right now. I was going to dramatically pull up the Discord, but I think I'll have to do that with a couple. Oh yeah, a few of my things broke when I restarted the broadcast software, because I have a theory that one of the issues I'd been having with freezing, some cameras freezing, was to do with just this broadcast software running for too long. So I quit it right before the show, and that unfortunately ditched a whole bunch of our presets. So bear with me, a little behind the scenes content here as I prep stuff. I think we're getting close. Let's bring Zed. And that looks like it. Yeah, so look, there's the Discord chat. And thank you to Dan Coliano and Thin Man and Tan Newt for coming by. As you can see, as you scroll back, there's been all sorts of people here throughout the day. Maybe some are still here. Smitka, who's the creator of Pico Game, which was a pick on Todd and Paul's Bootloader podcast, which was an excellent episode. Go check that out. They picked Pico Game as one of their faves, and I believe Foamy Guy, Tim, is going to be doing some game jam action with that. I haven't checked it out yet. I'm excited to check it out. It's 2D game engine for CircuitPython. And hey, Scott, Tan Newt just waved. Nice to see you. Great job on the show earlier. So that's one place you can go and check out our chats if you're somewhere that doesn't appear to have one. We do also have the YouTube chat. Hello to NetVentive. There, happy CircuitPython Day to you as well. And Burton R, hello. So, moving on with it, this is, my gosh, there's so much purple. This is the coupon code for the day. Wait, let me make it exactly the color of my shirt. There we go. That's helpful, right? CircuitPython Day, CP Day. That is your coupon code today. Let me move this up. You can't even see it anymore. Look, right over my head. CP Day, that is going to save you 15% off in the shop. It's bigger than usual. Normally we do a 10% off during the show, but for CircuitPython Day, you can save 15% in the shop on almost anything. You can't get gift certificate subscriptions or software and certain Raspberry Pi items, most of the computers and I think the NVMe drive, but almost everything else in the shop, first party, third party, any party you want, save a whopping 15% off in the shop today. Throw some stuff in your cart. On the way out, look for the little field that says coupon code. Type in CP Day. That is going to save you 10% off in the shop today. Look, it's moving all around. Why is it doing that? Just for fun. So CP Day, that's coupon code of the day. I'll remind you later. But if you want to save some money, you want to buy some cool Adafruit stuff, do it. That's the way. All right. Next up, I have a show on Tuesdays. That is the Product Pick of the Week show. This week, it was our first foray into cool white, warm white, amber white, 3 LED diode NeoPixels with this 8-pixel stick. Here's a little recap. It is the NeoPixel stick 8x5050 WWA white LEDs with integrated driver. You and I know it as a white, amber NeoPixel stick. Cool white, warm white, and amber. Here is the cool LEDs on there. So I'd light that up. We'll get a nice cool, almost slightly bluish light. So we've lit up the cool white LEDs. We go to warm, so you can see we've switched the lighting there. This is the amber diode, so when I hit that, you can see really, really orangey, ambery amber. So there we go. So you can see this is really nice for dialing in a color temperature. I'm just doing it by eye. I don't have a meter or anything on here, but if I want to get that skin tone, let's say similar to my own skin tone, it is the cool white, warm white, amber NeoPixel stick. Yes, it is. I'm excited that we have those, and maybe we'll get some others. Some circles, some matrices, some flexible strips. Could be neat. Also joining us in the chat, John Nodge. Hello, John. Gives the wave. Nice to see you. Let's jump on over to, I'm going to turn on a little speaker here. Oh, we have a note in the chat. Liz was writing CP Day with a lowercase d-a-y and asking if it's case sensitive. I am unsure if it's case sensitive. I thought they were not case sensitive, the coupon codes, but in case, just in case, that's case sensitive. I'll put it like this. CP Day. So try that. Try it all caps. Try no caps. Thank you, David. Next up, it's time for a CircuitPython Parsec. Okay, I think we've got this all set up. For the CircuitPython Parsec today, I want to talk to you about another one of our FruitJam library modules. And today it is audio. So FruitJam, this little gizmo right here, packed with all sorts of hardware. CircuitPython, we have this convenience library, sort of high-level library called the FruitJam library, and it gives you all these different peripherals that you can work with that are built onto the board. So we know what's on there. We don't have to have a specific call to a particular codec if we want to use audio. We don't have to tell it what pin to use NeoPixels if we use this library. You can, of course, but with the library it makes it really, really simple. Today I want to talk about audio playback. So in this case, I'm going to use the FruitJam peripherals audio output, and I'm going to use wave playback. So let's do a little demo of it first, make sure that we can hear this. So I'm playing over a little speaker here. So I can stop, start, stop, advance to a different song, play that, advance to the next song, and you can see, oh, that one's loud. You can see the little feedback in my REPL here is saying the song name. So as I switch using the FruitJam button, number 3 there, I can switch among the 3 WAV files that are on the file system. I don't think I used an SD card, it's just on the file system. And if we take a look at the code, what we do is from Adafruit FruitJam peripherals, we import peripherals. Then I have set up a directory with the WAV files in it here, this little variable here, wave_dir. And then we create the FruitJam object by saying FruitJam equals peripherals audio output, and I'm specifying headphone. We also have a little speaker built on, but I'm just using the headphone. And I'm increasing the safe volume limit. We actually have a volume limit of, I think, 0.75 by default that keeps the speaker from blowing out if you're using the little tiny speaker on there. But we're not, so I've got this kind of cranked up to 0.9. And then I'm doing some typical file system stuff to grab some raw WAV files to play, and a little bit of print stuff here to show those status lines. I'm also using the FruitJam button library. So remember we covered that a couple weeks ago. I can just say FruitJam button and I get a value of true or false when I press these buttons. Then in the main loop here, to play these back, it's simply fruitjam.playFile, and then we give it a file name, and you can say wait to finish, true or false. So any of those files that are being played, it's with fruitjam.playFile. Any file we want to stop, it's just simply fruitjam.stopplay. That'll stop the playback. And then I think, yeah, we can check if it's playing. I'm using fruitjam.audio.playing to see if we're done or not. And so that is how you can use the FruitJam library's peripherals for audio playback on the FruitJam inside of CircuitPython. And that's your CircuitPython Parsec. Okie doke. Just checking back with the Discord chat there. Okay, John Nodge, thank you for confirming this. All lowercase CP day worked. David, I expect you're right. Camel case, every other letter, lowercase, uppercase, that'll probably work as well. Good. I like when things are not case sensitive like that. That's helpful. Okay, so as I mentioned, I wanted to do a bit of a little retrospective on the CircuitPython parsecs of this year because it's a somewhat of a glimpse of features as they are added and evolve here in CircuitPython. So let me set up a little browser view here. Yeah, okay, so let's get that browser view right there. I can make that a little wee bit bigger. So all I've done here, I have a list I'm going to look at, but as a visual, I've gone over to the Adafruit blog and just simply typed in CircuitPython Parsec, and that shows you post after post after post after post after post. It's kind of a fun strobe animation if you go fast enough with that, of the CircuitPython parsecs of this year. So I do these once a week with the during this show, during the workshop show. And here's the topics I've covered. So starting back in January, Circuit Playground Bluefruit iPhone camera remote trigger, and followed by a Bluefruit iPhone intervalometer, so taking pictures from a Bluetooth remote on your phone. I did some NeoPixel stuff with NHOP cardinal neighbors, making like starburst patterns and things with NeoPixels, as well as a full starburst tutorial on the trellis. Some line fills between pixels on the trellis. Did a trellis Wordle scoreboard, the NeoTrellis MIDI keyboard, trellis MIDI note visualizer, trellis MIDI velocity meter. Then some modulo pixel wrapping, also related to that, getting pixels to wrap back out to the beginning. The Clue magnetic polarity finder, UART display write, external monitor rotation, that's related to the FruitJam and maybe something we'll cover a slight different take on, but being able to adjust the output on a monitor, any of the sort of cardinal directions of 90-degree rotation. We did DAC volume control, the smooth noise road, which was a noise sort of ASCII art feedback in the REPL. RGB LCD character display shield basics, and then I did a bunch of little game-like things on the LCD character display, including the buffer, custom glyphs, animation, using the buttons built onto the shield for movement, and then a marquee scroll. Did some display I/O nested display groups using vector I/O and display I/O. Bitmap rotozoom rotation and bitmap rotozoom zoom. So there's kind of two major things that we can do with those. And then Fruit Jam library topics that we're on now. We did buttons, we did NeoPixels, and today we covered the audio. So that's a look at some of the past year in Parsec topics. There is also a playlist, by the way, if you're interested in catching up on those. If you head over to your browser, go to YouTube, and go to the Adafruit channel, you can go to playlists, and you'll find a CircuitPython Parsec playlist in here, right here. So that'll show you all of the CircuitPython Parsec videos. It is, yeah, those are pulled out. Yeah, those should just be like a few minute segments each. There's no main live stream including those in that playlist. So that is a way to catch up on those. And as always, let me know if you have topics that you'd like to see me cover in CircuitPython Parsec. Thank you, Todd, over in the YouTube, or in the what's that thing called? The chat, the Discord chat. Posted a link to that. Appreciate it. So next up, speaking of retrospectives, let's take a look at some Learn Guides. So I'll bring back my browser here. If you just go to the Learn section, I did a little bit of filtering and scanning for some CircuitPython-based projects I've done over the last year. And so here was one, the Bluetooth scanner, and this used our Bluetooth abilities inside of CircuitPython to be able to sniff the air for advertisements, different BLE advertisements, and do a little bit of cross-correlation of some of the message that you get from these advertisements, even some objects that don't include their real name, to figure out if things are probably an iPhone or an iPad, because they've got a packet saying, yeah, I'm doing handoff mode. So they tell you that, but they don't tell you the name of the thing. So there were a few different devices that we were able to scan for, just to kind of see what's showing up around you. And the Clue's a nice gizmo to do that on, since it has the Bluetooth with the NRF52840, and CircuitPython makes it pretty easy to set something like this up using display and buttons on there. Let's see, I did a little e-paper camera, so using our Memento and some Adafruit I/O, I was able to snap pictures, turn them into a dithered sort of Game Boy style. There you can see Lars looking like a Game Boy style Lars. Low resolution black and white image, and then send that up to Adafruit I/O, and then back down to this MagTag. Is that a MagTag? Yeah, MagTag with the e-ink display on it. Looks really nice. So that was another CircuitPython project taking advantage of Adafruit I/O. There were a couple things involving ESP Now. So with some of our boards, this was the QT ESP32S3, we're able to use ESP Now, which is kind of using some of the same network as Wi-Fi, but it's not Wi-Fi in the sense that we're not requiring that stack and hubs. We're able to speak directly between these devices, or we can do little meshes with them, which worked perfectly for these juggling balls. So these were, I set these up using an accelerometer and a MIDI message being sent over ESP Now to a base station so that we can play MIDI notes triggered by throwing or catching of these balls. And I also had a color adjuster on the computer side. We could send through the little ESPNow hub that was plugged into the computer. We could send messages saying, "Hey, let's change the color on the juggling balls." Here also was more of a primer on ESPNow, so not built around a whole big project, but just simply, can we get these two boards to essentially send and receive messages with each other quickly over this nice, robust wireless protocol. I built a little knobby sequencer here. I think this was we have a quad rotary encoder breakout using Stemma. So I2C based, these little I2C based boards make life really easy. It's plug and play. There's no soldering involved, and you can string a whole bunch of them together, as you can see here, running on a single CircuitPy RP2040. And I was using these to sequence different note values, as well as randomizing them and using a little strip of neopixels to show us which note was playing, sending out MIDI, and then I was playing it back on this little black box sample station. Here's another Bluetooth one. In fact, I have that one right here. Doesn't want to focus, but there we go. There's my little, it would have been funny if I had this set up to mute or unmute, right, and forgot, but it's not right now. This is a single button Bluetooth keyboard, and it's pretty straightforward to adjust what you want it to do and send commands to things like, in this case, a computer that's, as you can see in that GIF there, changing between different tabs. So sort of, I don't want to do a lot of not chording, but Morse code to the thing. Or I think if I remember correctly, I had it set up just with a long press or a short press, do a couple of different things. But depending on your patience for tapping out rhythms, you can do more. You can extend that. So that was another Bluetooth and HID style project. Oh wait, I'm lying. Was this an Arduino? I don't think I did. Did I do this one in? It's Arduino. Forget that one. That's a lie. It's CircuitPython Day, and I'm here lying to you. Hey, here's one that I think was in CircuitPython. This was my Fruit Jam Chiron, which unfortunately, when I restructured some things, I ran out of HDMI objects to plug in and deal with, so I'm not using it right now. But it's this was CircuitPython going on to our one of the Adafruit stock. There's a real-time stock API page, and finding out the price of an object, since those changed during my product pick shows, it was able to show the current price. And since it's able to, on the Fruit Jam, this was running, able to display a solid, I was using blue and then just chroma keying that out so that we could do these types of overlays in real time. So yeah, that one was in CircuitPython. All right, so that's a little look at some of the projects from the last year using CircuitPython, and one bonus one that I'm totally lying about. All right, let's see. I'm just going to check my feed here, see if there's any questions or things going on. Oh, we're good. Okay, so the project that I wanted to talk about this week is one that I started looking at a little bit a couple of weeks ago, I think it was, and it is this, I'll show you the overhead view. It is this kick drum pedal that you see next to the computer there. It's a Lesis brand, and it is essentially a piezo sensor inside of a little small kick drum pad, neoprene pad, and it's got a mallet on it and the full sort of return and spring and chain drive that allows us to play the kick drum, and that's designed for presumably an Alesis kick drum kit, but it uses just a simple 1/4-inch jack, a TS 2 conductor jack, just like a guitar patch cable, to send out an analog value. So it is able to capture the velocity with which you hit it, which is great because we can then use that for MIDI velocity or other things. I'm using it for MIDI velocity. So when I hit a note, how hard did I hit it? And then what do we want to do with that? So the last time I showed this, I just had it hooked up to a voltmeter, but this time I've got it hooked up to that little Metro RP2350 you see there, and then that is running into my little laptop. Laptop is running, you can see a little REPL there with some text at the bottom. It says hit, the raw power value, the velocity that we translate that to, and the note. And I'm always sending note 36, which is a typical kick drum note value in MIDI, in the sort of general MIDI description. So that one, you don't have to remap things. If you just send out 36 and then you use a MIDI drum kit, you're really likely to hit a kick drum, which is great. And then this is being received. I'm sending that value, the velocity and the note on off, over USB MIDI to that laptop. Laptop is, you could run kind of any synthesizer or other music software that can accept MIDI with velocity to trigger a sound. And I'm running a copy of Ableton Live in there. And what I'd like to do is just show you a quick demo of that, and then we can also take a look at the code for that. So let me switch views, and I'll put my, oops, that's not what I want. I want this one, and I want it real small, and I want it down there. So I'm going to turn on, there's a mic over the workbench there as well, and I'll hold up this little speaker so that you can hear it. Unfortunately, I didn't have time to get a larger amplifier hooked up, which to hear bass sounds, you're not really going to hear them too well coming over the laptop speakers. It's a little better over this little speaker here, this little powered speaker. So let me turn this back off and on. Okay, and I'm going to point it right at that microphone there. So let me open up my chat on the phone in the Discord. I'll at least be able to look at that one. And just let me know if you can hear this well enough for the demo to make any sense. So here we go. Let's check laptop output volume. Here we go. I think I'm clipping a little. Lower it. I think that's a little better. So you should be able to hear the difference between these little light hits, and when I hit it harder, it's a little louder, a little stronger, but it also has more of a sort of reverb tail on it. So and that is all to do with what the software, in this case Ableton, is how it's interpreting that velocity. But as you can see here, hopefully that's big enough. That right there says velocity 127. These little hits are velocity 8, 17, 12. And so that's all I've just simply got a ground and analog in on the RP2350, and also have I believe I want to say it's a 1 mega ohm resistor between them to just deal with any of the really transient spikes of voltage that you get off of these piezo's. So that's all there is to the demo. It's just a velocity thing that hopefully you can hear. And I'm just going to check in on the chat to see if that was audible. Let me know. So what I'll do now is let me unplug the Metro. All the software is going to get mad that just disappeared. And I will let me unplug. So you can see here I've just got a 1/4 inch jack. That's how this drum is set up here. Little kick pedal set up here. I have a little tiny sort of guitar pedal patch cable there to connect, and then we actually sell these in the shop. These are little 1/4 inch DIY jack that I just soldered a couple of jumper cables to plug into the Metro. So that's what that looks like there, just running into these two ground and analog ports, and then I just crammed in the the resistor in there too. So you could also probably bury the resistor inside of the jack for this kind of use, but I want to be able to change out the value more easily. So I'll show you what that software looks like. And question from the chat from, bring this up, Cooper was, are you just taking and passing through USB audio to Ableton, or are you detecting the impulse on the RP2350? Right, so that, there's no audio, there's no USB audio involved, so I'm not synthesizing a drum sound on the Metro, I'm using the Metro just to send a USB MIDI command. So the MIDI on-off and the velocity get triggered by the pedal. That's all the pedal is being used for. The Metro then interprets that analog value as a MIDI note velocity, kind of remaps it to a velocity, and then sends a MIDI note out over USB to Ableton on the laptop. So laptop, for all intents and purposes, thinks that you're hitting a velocity-sensitive MIDI keyboard or drum pad kind of thing. So this just adapts it for that. So hopefully that answers the question. And let me go ahead back over to this little setup here. You can see it. Plug that in over USB. And let me see if I can convince. I may have to recapture Z here after closing and reopening. Yeah, I'm going to quit and relaunch Z, and I'll just have to point us back. It's acting up. So maybe I need to look at the, what was it, RV Circuit Studio that Paul was showing during the bootloader. Maybe I need to look at that a little more closely because Z is driving me a little bonkers. Okay, oh, so it showed back up, that's nice. You can see here, so I have a little calibration routine that runs at the beginning that checks for the noise floor, and then I hit the pedal a number of times to get the top velocity from it. It could probably be refined, but this was the sort of first run of doing this little calibration. We do have some default values in case you don't do that. And then we have some variables here that you could change if you needed to. For example, I'm on MIDI channel 0. You could go any of the 16 MIDI channels. MIDI note, like I said, 36 tends to be a kick drum or bass drum. And then the note on duration is how long to have that before you send an off. Since you're never really holding that down, you're just hitting it and getting off of it with the kick pedal. Setting up an Adafruit MIDI USB MIDI channel, and then we have sample, grabbing that sample off of the ADC on analog pin 0 there. Here's my little calibration routine, and a little conversion of whatever that raw velocity value is to the 127. So MIDI just, I mean, MIDI back in 1983, they wanted for some reason to keep it 7-bit, so sort of default MIDI 1.0 is only 127 shades of velocity. MIDI 2.0 increases that like exponentially, but you've with the kick drum, I think it's probably fine. It's not super nuanced, but that's what we get is 127 levels of velocity for that. And in the main loop here, we're just simply waiting for a note off message and sending note off or note on message, and sending that MIDI note, MIDI send, note on, MIDI note, and then whatever velocity we got from that conversion. So that's the basics of it. I'm not sure what use I have for it other than, well, now I've got a kick drum for my computer. You could use it for other things, but you know, most of the time a simple on-off switch foot pedal is fine on a computer. If anyone has ideas of what to use it, maybe you could use it to set the volume on your computer, and how hard you hit it is how hard your volume on your computer is. Something like that might be fun. But yeah, again, you know, pretty simple to set up this kind of stuff in CircuitPython and very quick iteration. So that was one of the reasons to do it that way. Just save the file and immediately get feedback on it. So I was happy to be able to use the Metro is great for this. Still one of my favorite boards to grab when I'm just doing a desktop project. So it's nice and big and easy to deal with, and it comes with the headers soldered on, so just plugging in a little jumper here was very quick and easy. Todd claims 127, that's more than enough variations to represent humans. Maybe. All right, so that is my project for the day, and then let's see, in somewhat less CircuitPython news, I'll just give a project update. I have been writing the Learn Guide, and I'm hopefully going to finish it today for the Space Invaders. This is the Space Invaders control panel I've been building. So this is using, it's too big for my printer, so I made some dovetails for it, for the case itself, and for, this is going to fall apart on me, the base, because it's not attached to anything yet, but this is, as you can see here, three segments for the base that screw into the, or the bottom here screws into the rest of it. You can see, let me set this off to the side. I've got my fruit jam in there with the HDMI, trying to get the camera focus, and USB-C available. Also, just I didn't want to go super involved with button pressing, so I just made this big enough to get in there. You just have to change some settings of monitor orientation. It's not something you'll do very often, but that's how you can reach in and get to those buttons. SD card is available there, and you put different ROMs on it. So this is for Space Invaders. I just finished building a 2.0 version of the wiring harness, so that's what's going to go in there, and that plugs right into the fruit jam there. So similar to like a button harness on an arcade game. Decided to put something together to make it a little easier to set up. So watch for that, and then I'll also be doing some, I think, abstracting that Space Invaders code, which is a port of the Intel 8080 code that Space Invaders ran on. This is in Pico SDK running on the Fruit Jam's RP2350, but Lamore asked me to take a look at doing an abstraction of that so that it's a little easier to port this to other chips if we do other chips in the future that are similarly capable to the Fruit Jam. We want to try to pull the pieces apart there so it's easier to drop in a different chip with different functions. So that's the project I'm working on, and I think that is going to do it for today. I'm going to get out of here and work on that. I'll give you a little breather if you are thinking of getting up, walking around, grabbing a cold coffee or something, and then come back to watch more. Let me check the schedule here. We've got some other shows coming up, and if you want, you can, here, I'll show you. Go to your YouTube, where'd you go, YouTube browser. You can just go to Adafruit, and there is a banner there for CircuitPython Day. Oh, that didn't go where I thought it would. Was that not the banner? Oh, all right, let's go to the blog. Stream schedule, top of the blog there. So we just had bootloader. I'm going to finish up here in a minute. Scott is going to be on at 5 with a deep dive, and then at 6 Tim will be on with a game jam. Thank you so much to Liz for helping put this together and for blogging stuff, everyone who got together to help out or to present shows. We had Noah and Pedro live stream this morning, Cooper with Liz hosting, Dan, Scott, and Tim doing what's new in CircuitPython, and then these other shows that I mentioned. So it's been a lot of fun. Thank you all for stopping by and hanging out. And don't forget, CP Day, no matter how you capitalize it, is your coupon code that's going to save you 15, I was going to say 10, but that's not it, 15% off in the shop today. Let me change the code there and make it real different. from my shirt. There you go. CP Day, that's going to save you 15% off in the shop. So head on over to adafruit.com, buy some stuff, save some money. That's the way to do it. That will turn into a pumpkin at midnight tonight, East Coast time, I believe. It's good for the day, so use it. All right, thanks everyone so much for Adafruit Industries. This has been CircuitPython Day episode of John Park's Workshop. I'll see you soon. Bye-bye.
Thank you.